statistics out because it's just really special. But Katie, did you want something to go out there to YouTube? Is there?
Mr. Gantz is the best teacher, so better listen up.
Whoa! All right. There's a test coming up, and she'd like a good score, so that's why I get very good. Thank you.
I love that.
Kaylee loves math. Kaylee also loves the Dominican Republic. Florida. Oh, Key West. Yeah, whatever. So, all right. So very good. All right. So we're gonna start with something that really looks kind of crazy and complicated, but it's not too bad. And we're gonna really try to prime your memory from previous stuff. Uh, I'll admit that this is one of those lessons that I've redone a couple times. It's hard to figure out just the right way to have it make sense. So I'm doing my best, but without a doubt, this isn't exactly my A lesson. You know what I mean? Like there's lessons I'm like, okay, this is really good. Like this is, I give myself C minus on this one, just to let you kind of forewarn. Okay, all right. I haven't figured this out yet. That's why I'm not qualified to teach a class exactly. All right. Would you agree the sine function looks something about like that? Okay. I did a really bad job of drawing that. Sorry. I'll probably just go like this. Is that better? Okay, and the domain of the sine function is from negative infinity to positive infinity. Who can tell me what the range of the sine function is? That means the outputs. The biggest value is 1, and the smallest value is negative 1. Very good. Okay, so what we want to do today is we want to examine the arcsine function. And you might say, well, what the heck is arcsine? Arcsine is the same as what we refer to as sine inverse of x. Now, the sine inverse of x is sometimes confusing for people because sometimes people write, say, 1 over sine of x, okay? And those are not equivalent expressions, are they? They're not equivalent. I mean, because 1 over sine of x is the same as cosecant, which is not sine inverse. So in order to kind of get rid of the confusion and get rid of this whole, negative 1 thing on top that sometimes people misunderstand, what we do is we say arcsine, okay? So arcsine means to find the angle, okay? So for example, maybe you know arcsine of 1/2. Anybody know if you take the inverse of 1/2 for sine, what do you get? 30 degrees, very good. So you get 30 degrees, because the sine of 30 degrees is 1/2, right? Okay, so there we go. So when we do inverse functions, these are inverse functions, we have to think about the properties. And if you remember, the properties are that the range becomes the domain, and the domain becomes the range, right? Remember that? This is from chapter 2. I know in the first semester, a long time ago, he's like, what? So the domain is from negative 1 to 1, and the range, we got to be careful, though. It's not negative infinity to infinity. And here's the reason why. You remember, if we were going to find the inverse of a function, it had to pass 2 tests. Number 1, it had to pass the vertical line test, and it had to pass a horizontal line test. Does the sine function pass the horizontal line test? It does not pass the horizontal line test. Okay? So therefore, you have to segment the function into just a certain portion. So if I only look at a small portion of the sine graph, say I look at this portion, is that now 1 to 1? Yeah, it is. And maybe you remember that when we looked at, do you remember what the inverse of e to the x is? Natural log of x. And so it's reflected over the line y equals x. So that's the relationship between those inverse functions, are reflected over the line y equals x. So it turns out that if we were to look at the inverse of the sine function, we actually get this. Now, its range is going to be from negative pi over 2 to positive pi over 2. I'll show you. Suppose we were to take the entire sine function. You get that, right? Well, is that a function? Does that pass the vertical line test? No, so you can't draw the whole thing. You can only draw a certain portion. Otherwise, it would fail to be a function. Does that make sense, dy one? So therefore, we just have that amount. Now, here's kind of the bigger idea. Take out your calculator. Press on. Go to y equals. Press sine of x. Hit window, and we're going to go from -2 to 2 and -2 to 2. And if I check out my graph, whoop, sorry, my bad. Mode, I need to be working in radians when I graph this stuff. Graph. Everybody agree that that's the sine function, a portion of it. Watch what happens when I go y equals, and instead of sine, I go sine inverse. That's a function as well, just like sine of x is. It's just not as pretty, okay? And when you look at that, you press graph, you can see you just get that small portion like we drew, right? Now, I'm going to try to bring this home for you, okay? I'm going to try to bring this home for you. Sine inverse. Can I take the sine inverse of 2? Because it's not between -1 and 1. Because sine is outputs between -1 and 1, right? Okay, so I can't do that. Okay. How about sine inverse? Can I do sine inverse of 0.5? Yeah. And mode, I'm going to work in degrees so we can, it's just kind of where our brains kind of work better. So sine of 0.5 is 30 degrees. Now, is that between -90 and +90? It is. So dy, you give me any number between -1 and 1. 5/8, so 0.625. All right, so we've got, do you get a value between -90 and +90? You sure do. Bling, give me a number between -1 and +1, whatever you want, anything. 0.125, 1/8, good. So we do that, and we get 7.18. So it turns out the sine of 7.818 degrees is 0.125. Is that between -π/2 and π/2? Is it between -90 and +90? Yeah, 7's between there, okay? So we got a fun decimal. Yeah, Riley. 0.98. Okay, thank you. That's that. So so thank you, Riley. That's great. So we're gonna do that. And I happen to know that the sine of 1 is 90 degrees. And so therefore, I'm guessing that we're going to get value very close to 90 degrees. But I can guarantee the output is going to be between -90 and +90. And you can see I get 81.88. Okay. Now, if I do that same, we'll do sine inverse. I'll do a negative value. We'll carry out these 9s a little bit further. Okay. I'm guessing I'm going to get a value very close to -90. And I get -89.97. Notice that all the outputs are between -90 and +90. Does everybody see that that's true? Your calculator can only produce values for arcsine between -90 and 90. If you want it to produce more, then you're going to have to do some trig. Because if it produced more, it wouldn't be a stinking function anymore, would it? See my point? Okay, so to bring this all the way home and get some closure before we move on to the other stuff, we go a little bit more quickly. Suppose we have 2 sine of x plus 1 is equal to 0. Now, you guys are extremely intelligent people. You're wonderful. You're beautiful. How do we solve that? Yeah, 2 sine of x is equal to -1. Sine of x is equal to -1/2. So we want to know where sine of x is equal to -1/2. So what we do is we decide where is sine negative. Second, third and fourth quadrants, as Dylan said, we inverse 1/2, we get 30 degrees. That means we have 210 degrees and we have 330 degrees, right? Are those values between negative 90 and positive 90. They aren't. So my point is this. These are solutions to the equation. Your calculator can't find them because it can only produce for sine values between negative 90 and positive 90. So because our solution set was here, we had to do some fancy dancy trigonometry in order to find that out. Does that make sense? So that's why we had to draw the quadrants. You guys understand we're doing this in reverse, right? We should have done 7.4 before we did 7.5. But I felt this would be too confusing to do on a video. Do you agree? Yeah, that's why I saved it. Oh, wow, again, so you're a good teacher. Thank you. I try to think about what I'm doing. Okay, so let's move on. Cosine function. We've got this thing going on. We're like something like that, right? Domain for cosine, negative infinity, positive infinity. Range, we got negative 1 to positive 1. So we know that these flip-flop. Okay, so we get negative 1 to positive 1. And then the range, we can't do negative infinity and positive infinity because we'll lose stuff. So your calculator has to decide at this point, what does it want to do in order to stay 1 to 1? Well, in order to stay 1 to 1, could I select this portion right here and be 1 to 1? No, I can't select that portion and be 1 to 1. That's just absolutely absurd. But I can select this portion and be 1 to 1, can't I? Yeah. So if you're to flip that, if you notice, what do you notice about the x values? The x values are always positive. So that means your range value, your y values will always be positive. In fact, your range values are going to go from 0 to pi. Okay, and that's why. So the arc cosine function looks like that. If I go into my calculator, I go into my window and I change the y value up here to 4, and I go into y equals, and I do arc cosine of x, and I'm in radians. There we go. And I press graph. You can see the arc cosine function that develops. See that? And you might not like the function, but that's just what it is. It can't continue on in its spiral, kind of like a double helix thing, right? Like DNA strand, okay? But it can't continue to do that because that would not be a function. So next time you guys are doing genetics and stuff in biology, talking about a double helix and DNA, I want you to raise your hand and say, that's not a function. It doesn't pass the vertical line test, and just see what she says, okay? All right? And if she says something smart about math, then raise your hand and say, math is better than science, and then just see what she says, okay? All right, because yeah, we have a kind of a war about that. Yeah. Oh. Oh, really? A double helix staircase. Cool. Like if I had $1 billion and I could like build my own house and like however I want, I would have staircases that were double helix staircases too. Yeah. Oh, you did the Nike? I want to see it. Okay. Yeah, I totally. It's one of my favorite things. Okay, arctangent. So I'm going to first draw the tangent function, and maybe you guys recognize that a tangent function has vertical asymptotes. Do you remember that? You love those. Great. It's good to love different things. Some people love, ice cream. You love tangent functions. So we kind of look at that or the tangent function. That's tangent. So if you were to flip it, it's gonna. Well, first of all, let's talk about the domain. The domain is gonna be from actually no brackets, negative pi over 2 to positive pi over 2, because it's undefined at 90 degrees and 180. And then the range is going to be from negative infinity to positive infinity. And what's nice is these can actually flip because tangent, does it pass the vertical line test? Does it pass the horizontal line test? Yeah, tangent's 1 to 1, isn't it? Well, at least between negative pi over 2 and pi over 2. If we were to draw more tangent functions, would it then pass the horizontal line test? No, but this one right here does. So we can flip it. The domain is negative infinity to infinity, and then the range is negative pi over 2 to positive pi over 2. And so as you graph this guy, we get this really cool graph right here. Okay, you see that? Now, I don't want to brag or anything, but I think I'm pretty accurate in the stuff I'm doing here. So I'm going to, I can make that y max value 2, and I'm going to go into y equals. I'm going to do arctangent of x. I press graph, and does that kind of look like my blue graph? Well, it sure does. Yeah. So you can see the type of shape that you get. Now, what this means is if I go mode and I go to degrees and I go arctan, what numbers am I available to take the arctan of? Anything. But the output has to be between negative 90 and positive 90, right? So give me any number. Anything you want. 17.4. Pi. Sweet. Let's do it. Cool. 72. 1 million. Let's think about 1 million here for a second. Tangent is sine over cosine, right? Sine is the y value. Cosine is the x value. Y over x is the same as slope. So if I'm doing the arctan of a slope of 1 million, what angle do you think would have a slope of about 1 million? Really close to 90 degrees, right? Let's do more than 1 million. Oh, you see it? It doesn't matter what number you punch in. You type in the biggest number you want. And your calculator cannot, well, maybe it will. Stupid calculator. That's totally wrong, isn't it? Can't be 90. Because if you do tangent 90, well, tangent 90, you get undefined. So your calculator is too stupid. Fortunately, we're smart. Okay. What about a slope of negative 1 million? You think it'd be negative. What about a slope of like 0.1? You're really close to 0. Arctan of 0.1, you should get an angle close to 0, 5.7 degrees. See that? It's kind of making sense how you're generating your values. Yeah, it's cool. All right, let's try a couple problems. Okay, arcsine of 1/2. You have to produce a sine value between negative 90 and positive 90. Now, it's true that sine is equal to 1/2 at 30 degrees and 150 degrees. But which one will your calculator produce if it does arcsine of 1/2? It will produce 30 degrees. So therefore, we say arcsine of 1/2 is 30 degrees. Everybody clear why you get that? Is everybody also clear that sine is equal to 1/2 at more than one value? Okay, but it just produces the 30. Tangent inverse of -1. Tangent is equal to -1 at either 135 degrees or at 315 degrees. It has to produce values that are between negative 90 and positive 90s. Which one will it choose? Negative 45. Negative 45 is the same as what? 315, isn't it? See that? Now your calculator will produce those values for you. How about cosine inverse of 3? Can cosine be equal to 3? No, so no solution. And so you can take this handy dandy calculator and you can do cosine inverse of, let's see, negative second root. Where's my root key? There we go. A 3 parentheses divided by 2. And, you get 150 degrees. Yeah, that's it. What? Because life's difficult. Thank you, Cole. Dylan. Because Leiwa wants a challenging unit. We already went over this. He's sick and tired of easy stuff. Thanks, Leiwa. Add 2 more examples. Gotta consider the source. I am scared. I'm scared. I'm petrified, terrified, stupefied by you. All right. What happens if you take inverse functions and you operate them on each other? Yeah, they go away. Can you take the sine of 1/2? Can you take the sine of 2? You can take the sine of anything. Can you take the sine inverse of 1/2? Can you take the sine inverse of 2? No, you can take the sine of 1/2. That's totally fine. Okay, so these cancel, and you're just left with, yeah, easy. Okay, next one. Right away, you want the cosines to cancel, don't you? You take the cosine inverse of 5. Could you take the cosine of 5? But you can't take the cosine inverse of 5. So even though you want to cancel these out, order of operations would say you would have to do the cosine inverse first, or cosine first, and you can't produce that, so this is a no solution. So I know that you want to cross it out, just say it's 5, but there's a little technicality there. You see that? Okay, so let's get to the problems that you're going to see on your test, on your review tomorrow, okay? These are the last 4 problems of your unit, all right? Tough unit, you guys made it through it. Congratulations. Next unit's easy. We just learn how to find the square root of I. Actually, we'll do the cubed root of 1 minus I roots of 3. Like, I'll teach you how to do that. All right, here we go. What? Genius. Nice. Okay, great. All right, we all feel better. Okay, so here's what we want to do. We want to evaluate this expression by sketching a triangle. It says, what's the sine of cosine inverse of 1/2? And some of you might recognize by looking at this that we know that the cosine inverse of 1/2 is 60, and that the sine of 60 is root of 3 over 2. Okay, but we're going to do it by drawing a triangle, because trust me, I don't think you know how to do the last one, do you? So we're gonna sketch a triangle here. Okay, whoop, I got out of whack there. We're gonna draw a triangle, and I'm gonna put theta, which you happen to know that theta is 60 degrees, don't you? Okay, congratulations. Suppose we didn't know theta was 60 degrees. What I do want to focus on is this cosine piece. I'm going to use some SOHCAHTOA. So in terms of opposite, adjacent, and hypotenuse, what is cosine? What's cosine of theta in terms of opposite, adjacent, and hypotenuse? Adjacent over hypotenuse. So that means that the adjacent side we could write as 1, and the hypotenuse we could write as 2. Is everybody good with that? Now here's what happens. If you do the cosine inverse of 1/2, you told me you get 60 degrees, right? Or in any triangle, if you do cosine inverse, you're going to come up with theta. So this guy right here becomes theta, right? So you're going to end up with an expression that says sine of theta. So really, this question is just asking, what is the sine of theta? When we're figuring out sine of theta, sine is opposite over hypotenuse, right? Do you have the opposite side? No. Can we find it? How? Yeah, so we got 1 squared plus b squared is equal to 2 squared. So we got 1 plus b squared is equal to 4, so b is equal to the root of 3. So if I want to then express sine, sine is opposite over hypotenuse. So it will be, and that's my answer. So let's look at the next one. Draw a triangle, put in theta, and go to work. Sine inverse of 4/5. Well, sine in terms of opposite, adjacent, and hypotenuse is? So I got opposite is 4, hypotenuse is 5. Anybody want to come up with that adjacent side? 3. So now, when you do sine inverse of something, you come up with theta. So really, this question is asking, what's the cotangent of theta? What's cotangent in terms of opposite, adjacent, and hypotenuse? Yeah, so tangent's opposite over adjacent, so this is going to be adjacent over opposite. So we get 3/4. Did I detect a question in the crowd? we recognize it's a 3, 4, 5 right triangle. Pythagorean theorem. Let's see. Tangent of secant inverse of 3. Draw a triangle. Make theta. So it is secant inverse of 3 over 1. So in terms of opposite, adjacent, hypotenuse, what is secant? Hypotenuse over adjacent. Hypotenuse over adjacent. Well, if you do tangent of secant inverse, secant inverse comes out to be theta, so we got tangent of theta. So we got to find the opposite over the adjacent. So we do the Pythagorean theorem. Very good, 2 roots of 2. So tangent theta is 2 roots of 2 over 1, or just 2 roots of 2. Kind of clicking? I start with cotangent. Tangent is opposite over adjacent. So cotangent is adjacent over opposite. The adjacent is 12. The opposite is 5. I'm going to find the other side of that triangle. It is another Pythagorean triple. Thank you, Mr. Gens, for the Pythagorean triple. Oh, you're welcome. So we got the cosecant of theta, because when you do cotangent inverse or arctangent, you end up with theta. Okay. Hypotenuse over opposite. Very good. I want to be clear, we could spend about 3 days on this lesson because we really did not investigate, arc secant or arc cotangent or arc cosecant. And for those of you on YouTube that are dying to learn more about that, I understand, but guys, I haven't seen any of that come up on any ACT problem, and I've never seen any of it addressed in calculus. So if you do come up with a calculus question like that, you'd have to do some further investigation, but I just don't see it as very meaningful for us to learn moving forward. So I leave it out. How's that? Would you like an assignment? How about your last assignment of this unit? 7.4, page 567. Numbers 1 through 4, 13 through 18, and 29 through 34. Sometimes Leiwa, did that match the level of difficulty you were looking for? Okay, thank you.